I want you to do these first two on your own. I should have told you that 3 minutes ago, right? So you could be doing them. All right. Do these first two on your own. I'm actually going to, all right, couple quick announcements. There's a couple things that are going to be on the next few quizzes. One is you're going to continue to see these kind of questions because I need everybody to be good at getting rid of the denominator and learning to use the common denominator, because when we get to rational functions, we need to understand that that will wipe out the denominator, multiplying through by the least common denominator. So what did you multiply through by on number 1? Oh, I did, but it's frozen. There you go. We're good. Common denominator was 6. Everybody understands why it's okay to multiply by 6? We can do anything we want as long as we do it to both sides, right? So 6x divided by 2 would be 3x plus 30 equals, what'd you get on the right-hand side? 2x minus 42. Okay. What did you do first on number 2, though? I'm assuming you can finish that one. Yeah, I would distribute first. What's 2/3 of 9, guys?
6.
Everybody okay with that? Then you actually, because there's only one fraction in one place, I might have done this by just taking 2 minus 2/3 and making an improper fraction. But it'll work either way. A lot of you hate fractions, don't want to think about fractions ever, so you could multiply both sides through by 3. Now, the other two things, remember I said a minute ago there's several things that are going to repeat over and over on the next few quizzes. The other thing is you're going to be given 2 ordered pairs, and I'm going to ask you the distance, the slope, the midpoint, and the equation of the line. The slope, the distance, the midpoint, the equation of the line. The equation of the line, the slope, the midpoint, the distance, okay? Until everybody can get it. Really, guys, those are Algebra 1 and geometry skills, okay? So nobody should be getting those wrong. So let's look at them as easy points. Other announcement, the next quiz we have is a no calculator quiz. Only I'm going to be nice and let you use the scientific calculator, okay? I should really make you take it as no calculator because part of the SAT in April is no calculator, the math portion. You have to remember how to long divide and all kinds of junk. Okay? But I know I would make a mistake if you gave them to me without a calculator and no multiple choice, right? So I will let you use a scientific calculator, but it has quadratic formula on it, and I want you to be able to do it without a program, because then I'll give you a program if you want. Okay? Here we go. This is all about quadratic equations. The first one, what can we do to solve this? Do we need to try to factor? You know what? I put this on a quiz, and everybody thinks that this says 5x and wants to factor, because you do so many like that. But there's only an x in one place, so we can isolate. You know what that means? Get the x squared by itself. So what do we need to do quick? Add 5, and then what? So we're using our algebra brain. Then what?
5/3.
Okay, now before I square root, I want to talk about this. What is the answer to this? Whoops. Okay, are both of those plus or minus? The answer to this is only +4. It's called the principal root. If I just ask you what's the square root of 81, you only tell me 9. There's 2 answers to this, though, because of this, right? Remember, for quadratic, and it has a little 2, there's up to 2 possible answers. That's because a +4 squared is 16 and a -4 squared is 16. If there's no squared, if it just asked you this, there's not 2 answers. But this there is. So let me explain the reason. I don't know how maybe the girls can tell us. Do they teach you have to do this when you square root? The absolute value? They teach you that in Egypt or no? When you square root, you have to do absolute value of x over here. And that's actually why it comes out this. I don't think of it that way. I just remember when I square root anything with an x in it, I have to do plus or minus. Is that how most of you think? Do you remember at all that you got two answers? I know it's really easy to forget the plus or minus, okay? You don't have to show that step to me. When you square rooted right here, if you went from this to this, I'm good. All right, let's try this one. This is far more complicated. Somebody is going to try to distribute the 3. Can I do that? No. What would I have to do first if I was going to do it that way? Distribute the square. Oh, I'm going to cry. Is x plus 2 squared x squared plus 4? You cannot distribute. You have to FOIL it out, right? But I don't want to do that. That's a lot of work, and I'm going to make a mistake. Because, let me tell you really fast what you'd have to do. You'd have to FOIL it out, then you'd have to distribute the 3, then you'd have to subtract 10, then you'd have to subtract 65 over to that side, and then you'd either have to use quadratic or factor. Okay? Did your head just explode? I would make a mistake. But we can isolate this. Can we use our Algebra 1 brain first? Just, I don't know what's happening. It's like frozen here. We're going to add 10. There we go. Plus 10 is 75. We're going to divide by 3. Now we're not in Algebra 1 anymore. Now we're going to square root. And really what should happen is we should say this. But we don't do that, right? What do we do instead? Most of us would not write that step. We would just write x plus 2 equals plus or minus 5. Same difference, okay? Right? Because absolute value means whatever was in there could have been positive or negative. Then we still have to subtract the 2. So we could write negative 2 plus or minus 5. And someone in pre-calc will leave that on their next quiz, and I'm going to take off a point. You're in pre-calc. Can you tell me what 2 values those are? You can write 3 or negative 7. You can write 3 and negative 7. You could even just put a comma there. I don't care. But there are 2 solutions. Okay? All right. Last one's easy. What are we going to do on this guy? Just square root, and we get x minus 3 equals, careful, plus or minus square root of 5. Now, somebody's going to write this. Plus or minus 3 square roots of 5. Sorry, I kind of crammed that in there. Is that the right answer? No, we have to add over there, right? You could, I suppose, write this. That's not wrong. But most of us would probably put the plus 3 out front. So when we added 3 over there, we'd say 3 plus or minus the square root of 5. Everybody okay? Did I lose anybody yet? Okay. We're going to do easy, hard today, okay? That was easy. And these are not hard. Unfortunately, completing the square is really important in pre-calculus. It is important to find the vertex of a parabola. It's important to find the center of a circle. It's important to find the center of a hyperbola or an ellipse. It's not called the center. It's a hyperbola, but all right. This is what I'm going to do, and somebody's going to say, but this is not the way Mr. Hardy did it. Okay. Now, this is where I might be different than someone else. We're going to add a blank to both sides, and we're going to make this a perfect square. I need to move that down. There's no room there. Can I do my magic? Here, let's see if I can do my magic. No, that eraser is not what I meant. I was going to try to move it, but it's okay. We're going to take half of that b value. And then we're going to take the square root here. So we're going to go x plus 3. Now, this is a little field trip back to Algebra 1. What is x plus 3 times x plus 3 equivalent to if you FOIL that out? Okay, so we already have x squared plus 6x. What do we need to add to that to make it equivalent to what we just wrote here? Okay, and that will always be this number squared. Okay, well, they told me that Mr. Hardy had you write something up in the corner here rather than putting the plus blanks and do a bunch of crazy bits. I don't know. They said, that's not how we did it. And I said, well, this is how I'm doing it because I want you to really understand where it's coming from. Okay, do you understand now that x squared plus 6x plus 9 is equivalent to x plus 3 quantity squared? Yeah. And because we added a 9 to one side, we got to add a 9 to the other side, yes? And 7 plus 9 is? Now, am I done? Well, I'm done in such a way that I'm back to what we just did, right? What are we going to do now? Square root, and remember to write, oh, I just wrote over the top of that, sorry. Plus or minus 4, subtract 3, what's negative 3 plus or minus 4 equivalent to? Negative 7 or positive 1? Anybody lost? Yes, it would have been easier to subtract the 7 over and factor that one. Okay? But it says up here we're practicing completing the square. Whoa! Or we're just making a big blob. Okay. All right, let's try this one. X squared minus 10x plus blank equals 11 plus blank. I'm going to actually move number 8 to another page in a second, because if I try to squeeze it in, then I have to write small and you can't see from the back of the room. So here's question 7, okay? What do we do first? Half of this would be minus 5, right? Take the sign with it. And when we square it, we get negative 5 times negative 5 is 25. Is this one going to turn out nice? Yeah, because we get a 36 over here. So can you finish? Square root both sides. 2 answers. Positive 11 or negative 1. Write it out, guys, if you need to. Don't make silly mistakes, okay? Write 5 plus 6, 5 minus 6, whatever you need to do. Use your calculator. All right, I'm going to take a picture of this one and slide it to a new page. It's my own little personal selfie here. Okay. What are we going to do here? This one is not going to come out nice because this doesn't factor. What do we have to do first, though? Yes, put the 4 on the other side. We got to get rid of that guy. And while I'm doing it, I'm going to write a blank on both sides. Now, you could use a decimal here. I'd really like us to get used to fractions a little bit because do you remember that whole pi over 3, pi over 4, pi over 6 in trig from last year a little bit? That's going to come back, and when we graph, we're going to have to be good at fractions. So we're going to play around with fractions as we go. So what's half of that going to be? 6.5, 6.5, or we could write just 13 over 2. Either one of those other answers is fine. I really would rather you didn't write 6.5, because then when you square root it, it just looks messy. All right, what's happening? Square that. Think about it a minute. It's not as hard as it looks. 169 over 4. You square the top and the bottom. Everybody okay with that part? Now this is where I'd probably use my calculator. But if I didn't want to, I could make 4 into 16 fourths and then add 169 over 4, common denominator. But I'm okay with typing it on your calculator, doing a math enter. Is it 185?
Yeah.
Okay. Now what? We're finally ready to square root, which will just give us x plus 13 over 2 equals plus or minus. Now, this is equivalent to the square root of 185 over the square root of 4, right? Which is really nice because the square root of 4 is 2, and now we even have common denominators, right? But we also don't have a radical in the denominator. Will that always happen? It'll happen as long as this was just an odd number, right? Because when we divide it by 2 and square it, we're going to always get over 4. But if it was something else, it wouldn't. Okay. Now we're going to subtract negative 13 halves plus or minus square root of 185 over 2. By the way, the square root of 185 is the square root of 5 and the square root of, what, 30 something? 5 goes in there 3 times, 2, 3 times with 30. Yeah, that's prime factors, right? Nothing's going to simplify there. Neither of those are square roots. The only other way you could write this is because they have a common denominator. If you wanted, you could write it all over 2. Does everyone understand that that is an exact answer? Okay, it's actually 2 exact answers, right? I'm not going to make you write it out twice, but it's negative 13 plus square root of 185 all over 2 and negative 13 minus square root of 185 all over 2. Okay, but I want an exact answer on these problems, not a decimal. All right. Factoring. How good are we?
Pretty good.
Okay, x squared is an x and an x. We're good with that. Factors have to multiply to make this guy and add up to this. So factors that make 9, negative 9 and positive 1, yes? 3 and 3 isn't going to make an 8 to the middle, right? To check, if you're not confident, do the little smiley face inside outside here. You get negative 9x plus 1x, and you get a negative 8 in the middle. Okay? Now, does everybody know why we do x equals 9 or negative 1? Why does that work? Why is that true?
Because we FOIL it all. It doesn't matter which order.
Okay. The only way to multiply and get 0, it's called the zero product property. The only way to multiply and get 0 is if one of them's 0, right? The only thing that'll give you 0 is 0 times some number. Nothing else will give you 0. So one of these has to equal 0. Either this is true or this is true. Did you realize that before? Some of you probably did, but some of you were like, it's just magic. We set them both equal to 0. But does it kind of make sense now? The only way to get 0 is if one of them is equal to 0. It's called the zero product property. All right, keep going. Factor this guy. What do we get? Plus 7 and minus 2. Is that working, guys? So the answer is, answers are, anybody not want to factor 11? When you see that one, you want to just add the 49 over and square root?
Yeah.
The difference is, if I add the 49 over and square root, about half the time I'll just write down 7 instead of plus or minus. If I factor, I always remember there's 2. And that's okay. Difference of perfect squares, we okay? Oh, I don't know what happened right there. All right, they get a little trickier. What do we have to do here first? There is no property that says two things multiply to make -8, and there's two specific things. There are infinite number of things that multiply to make -8. Okay, we can't do it with a -8. We have to make it a 0. X squared minus 6x plus 8 equals 0. When I teach this in Algebra 1, I call it the take your turn, be an equal to 0 game. That's a Miss Falzone-ism. Some of you know Miss Falzone. Aunt Pet lives by Miss Falzone, I think. X and X, factors of 8 that make 6. 4 and 2. To get a positive 8 and a -6, we need 2 negatives. So X is either 2 or 4. Okay. What about when you have a coefficient other than 1? It's a little more complicated just because this one only has factors of 2 and 1, right? But you either have a 3 and a 1 or a 1 and a 3. You got to do your little smiley business to double check that it gives you what in the middle here? -1. How's it going to go? So I have a positive 3. Nope, I need a -3 and a positive 1, right? So when I do this, I get -3 plus 2 is -1. I didn't even bother to move that over, did I? Sorry. Just saw it as a minus in my head. All right, somebody's going to write this down. The little take your turn, be an equal to 0 game says that it's not 3. It's what? Add 3, divide by 2. So we have 3 halves and -1. All right, can you do number 14 on your own? And then come get a piece of candy. What's that weather doing out there for tennis? Is it nice or is it still really humid?
I don't know. I
Haven't been outside.
It's really, really hot. Yeah, it's probably.
It's hot again. Okay, somebody asked earlier today, said we're out of caramels. Now I know we got to get more those butterscotch things, huh? Okay, caramels, butterscotches.
Butter and cream cheese. Those are my favorite. I love those.
All right, guys, that brings us to quadratic formula. When it doesn't factor, which there's no guarantee some of these don't factor, but I'm going to just say that I want us to solve all these by quadratic. I don't think any of them do factor. I don't know. Anyway, we're going to use quadratic. The quadratic formula says if ax squared plus bx plus c is equal to 0, it only works when we get it equal to 0 first, okay? Then the opposite of b plus or minus the square root of b squared minus 4ac all over 2a is equal to x. All right. If you're doing this on your calculator, you're going to want to remember to put the b in a parenthesis here before you square it. And you're going to want to put the 2a in a parenthesis because if you did the whole thing divided by 2 and then times a, that is not the same as the quantity 2a. I want an exact answer anyway, so you're going to type all this in your calculator? No, because it's going to give you crazy decimals most of the time, right? Okay. What are a, b, and c on 15?
1, -4, and 1.
You don't have to write that down. I know you know how to do that part, right? So now we got to plug all of it in here. The opposite of b is positive 4. Oh, we should write x equals, but I never remembered to do that. Positive 4 is out there, plus or minus the square root of b squared, and I always just write down 16 because I don't want to have to write parentheses squared, because everybody knows if you do this on your calculator, that's going to give you negative 16, right? It squares it and then takes the opposite. Okay, so I just write down 16 usually. And then minus 4. That 4 is part of the formula up here, right? That came from up there in the formula. Times a times c. All over 2 times a. All right, so we get 4 plus or minus the square root of. We get 16 minus 4 in here, which is 12 over 2. Okay. Do you remember me talking about this yesterday? When we were doing the yellow sheet?
Wait, what? I was not here yesterday. I missed this.
Can you cancel the x squareds right there?
Oh, no.
No. Because there's glue, right? They're glued together when they're by the addition or subtraction. Actually, that one doesn't factor and reduce at all. Whoops, wrong way. So on this question, somebody is going to do this. Can't do that because it's glued to this thing, right? What I do and help to do is I separate them with the plus or minus so that I'm not tempted to cancel anything, okay? We do need to reduce this though. Most of you, I hope, remember how to do this. 2 square roots of 3. Now, all I did was say both of those are over 2. Yes? I split the 2 and said both of them are over 2. Now it reduces to what? Can I reduce now? You get that this is a fraction now, right? Or there's no glue holding these together, so we get reduced to 2 plus or minus. This is a multiplication, and we're allowed to reduce multiplication. Okay. If you had written this as 4 plus or minus 2 square roots of 3 over 2, some of you would have... You shouldn't leave it. It's not simplified. But some of you would have been fine with going straight to 2 plus or minus the square root of 3, because you would have remembered that both of these have to divide by the 2. But somebody else would have crossed one of them out and not remembered, okay? So either way. Let's try another one. Opposite of b is what? 6 plus or minus square root of, can I just square it this time? B squared is 36. Everybody all right? What's going to get somebody on this one? That negative 5 back there, right? Type it in your calculator so you don't get it wrong.
Oh, no.
It's not imaginary. Yes, because this minus 4 and this negative 5 are going to come plus. There aren't any with imaginary answers tonight. 6 plus or minus the square root of, let's see, that's 76 over 4. Okay, 76 actually reduces. It's the square root of 4 times the square root of 19, is that right? So I end up with 6 plus or minus 2 square roots of 19 all over 4. But is it going to reduce? So I'm going to go ahead and write it over 4 here and over 4 here. You don't have to do it that way. I don't care. That would be 3/2 plus or minus what? Square root of 19 over 2. Now, because those have a common denominator, that is equivalent to writing 3 plus or minus the square root of 19 all over 2. I don't care which way you write it. Fond memories of quadratic or not so much?
Just the imaginary numbers.
I don't think it's hard. There's just so many places to make a little mistake, right? Okay. What do we have to do first on this guy? 3x squared minus x minus 6 equals 0, because remember the whole formula up here said it had to equal 0. All right, opposite of b, anybody? 1 plus or minus the square root of, what is negative 1 squared? 1 minus 4 that comes with the formula times 3 times negative 6. Whoops, that's a really long fraction line. Oh, that didn't help. I'm going back with the long fraction line then. All over 2 times 3 or 6. 1 plus or minus the square root of. This is 72, positive or negative? Plus 72, and that 1 makes it 73. Oh, that's not what I wrote. That was a serious...
We all have those.
Oh, now I'm trying to write with the eraser. 73 over 6. Is there any reason to separate that one? You could, but it isn't going to reduce, right? If you wrote 1/6 plus or minus square root of 73 over 6, it's all good. 73 is prime, yes? Not going to factor or reduce. All right. Part of what we just did, if I asked you to only solve questions that had real answers, you could use what's called the discriminant. Or if you wanted to know ahead of time how many solutions does a quadratic equation going to have. The problem is I'm going to ask you on the test or quiz, what is the discriminant? And you're all going to go, I don't remember what that means. Okay, you need to remember this vocabulary. The discriminant is the part of the quadratic underneath the radical. And it predicts for us because this happens. When I do this, if this is a 0, is all this plus or minus going to mean anything? I'm only going to get one answer, okay? So if b squared minus 4ac is 0, then I'm only going to get one solution, and it will always be a real solution, as long as a, b, and c were real numbers. All right. The other thing is, if this is a negative number in here, what happens? We get imaginary answers, right? Which for today we're going to say means no real solutions. So if b squared minus 4ac, right here it says, has a negative value, then there are non-real solutions or imaginary numbers. So we're going to say no real solutions. That's supposed to say no reals. All right, what's the other option? It could be positive, right? If this number here is positive, then we get two solutions. B squared minus 4AC is greater than 0, or positive, and we get two real solutions. Now, I'm going to talk about something for just a second here, and some of you are going to just tell me you don't care, but if what's under here happens to be a perfect square, does anybody know what kind of real solutions we'll get? You get rational solutions, it's called, right? Because you'll get a nice number. Everybody okay? Okay, they're called rational solutions. It could still be fractions when that over 2, but you're not going to get crazy decimals or irrational solutions. It's not going to have a square root anymore. But any other positive number will result in two crazy decimals or irrational solutions. Okay, back here. The problem is it's going to say on a test or quiz, find the discriminant. And that's the part you're not going to remember how to do. So how do you find the discriminant? B squared minus 4AC, which is going to be, this is 25 minus 8 is 17 on this one. Did somebody else get that? Now, determine how many real solutions exist. What are we going to write? Two real solutions. Again, because if I took the square root and I put it in quadratic, I'd have plus or minus square root of 17, yes? So I'd get two answers. All right, what about this next crazy one? That's a lot of negative numbers back there. Did I do it wrong? Yes? We good? So how many real solutions? No real solutions. You could write 0 real solutions. Eventually we're going to talk about there will be 2 imaginary, right? All right, what's the other option? Wild guess what this one's going to be? B squared minus 4AC is 16 minus 16 is 0. What does that mean again? If it's a perfect square, there's 2 rational. But if it's 0, it's negative b plus or minus 0, so you only get 1 real solution. Yep. And it is rational. That one solution will be rational. Either a whole number or a fraction.
Is there any instance in math where you would take the square root of infinity?
Not that I know of, but I'm not the mathematical and be-all and end-all. There's way smarter math people than me, but I don't know why you'd take square root of infinity. Because, yeah, square root of infinity is still going to be an infinitely large number. Can you do this one on your own, guys? How do you determine? It's a multiple choice question. How do you determine that? Just use the discriminant. Yep. The discriminant turns out to be I got 144 minus 144, right? If the discriminant is 0, the answer is 1 real solution, which they nicely called a unique real solution. All right, so your homework is to work on worksheet 2A and B. Now, there were several people, let me turn this off.